All right, these are the Unit 6 practice problems. I tried to take different data tables or different molecules from secure questions, change the question so that they're similar but, a little different. So question 1, it gives some unknown substances and students are supposed to decide which one of those would have to represent a solid with ionic bonding. So you look at the melting points, they're all, relatively high. So that's not really going to help designate which is the ionic. Then you go to electrical conductivity in a solid phase, and you see that Y is a good conductor. So that definitely rules that as being ionic, and that must be a metal. So we're going to leave off Y. Then we go to conductivity in a liquid phase. Ionic, as we said, if they're melted or molten, then they should be a good conductor. And then it seems like X would have to be a covalent compound. So that gives us C as an answer. Going on to the next question. Question 2, we see a table of structural formulas, and then we also have molar masses. Based on the information in the table above, which of the compounds has the lowest boiling point and why? Well, we would expect the substance with the lowest boiling point to have the weakest intermolecular attractions, and so the molar mass really is there just as a confusing detail because it's really not about molar mass, it's about what's in the molecule. If we notice the middle compound is all carbons and hydrogens, and hopefully students would recognize that as being a nonpolar molecule. The other two compounds both contain an oxygen, which would make those molecules polar, and then even the propanoic acid has the OH, which would be sites of hydrogen bonding. So we would expect the pentane nonpolar chain, that narrows it down to B or C. And it's not about the longest carbon chain. It's about it would have dispersion forces between molecules, which would be weaker than the hydrogen bonding and dipole-dipoles forces of the others. Number 3, which of the following is most likely describes the solid represented in the diagram above? Hopefully students should recognize that as positive and negative ions. It does say, A, it's soft and a poor thermal and electrical conductor. We don't think of ionic compounds as being soft. For B, low melting point and poor conductor. Well, poor conductor would make sense for ionic, but it doesn't have a low melting point. And then we get to C, it is brittle, water-soluble electrolyte that is a good thermoelectrical conductor, and that does sound like an ionic compound, so C is the answer. If we go on to D, we can definitely see that would describe a metal because it's malleable and is a good conductor. So C is the best answer there. All right, number 4, which of the following best helps to explain why Br2 is a liquid whereas I2 is a solid when both are at 25 degrees Celsius? And if we think about their structures, they both have single bonds, covalent bonds between their atoms. And since that means they're a molecule, and since they're just, the same atom bonded, that would be a nonpolar bond in a nonpolar molecule. So we're looking for a difference in London dispersion forces. So if Br2 is a liquid and I2 is a solid, we would know that the solid form would have stronger London dispersion forces between the molecules since it's keeping that in that more regular structure. So we could see the answer would have to be D. The London dispersion forces are stronger in I2 than in Br2 because I2 has a more polarizable electron cloud. For number 5, we can see that has the speed of molecules and the fraction of molecules, and usually this is a temperature question. And, the higher temperature is really the more spread out curve because more molecules have a higher average speed. But then the question says which gas has the greater kinetic energy, and it just said that they're at the same temperature. So if they're at the same temperature, the two different gases, which one has greater kinetic energy? Kind of a trick question. That's what I mentioned in the other video. That would be C. They both have the same kinetic energy. They're both at the same temperature. If it said which one had, a higher, would be a higher molar mass, it would be A, because it's moving at an average slower speed. If you drop a line straight down from the peak at A, then that would have to be a heavier molar mass traveling at a slower speed, whereas a lower mass, something like helium gas, might be B, since it would be traveling faster because it has a lower mass and both would have the same kinetic energy. All right, 6. Which of the following best helps us to explain why the value of the enthalpy change for the dissolving of sodium hydroxide in water is negative? So that's saying it's overall exothermic. And if we remember those 3 processes that occur, we've got 2 endothermic processes, and then the attraction between ions and the dipole water must be releasing a lot of heat. So our answer there is D. It's that attraction that's releasing heat. Number 7, which of the following conditions of temperature and pressure will helium gas be expected to behave most like an ideal gas? So again, if we want the molecules to not be attracted to each other, they need to have a lot of energy, so that would be a high temperature. And we want them to be really spread out, so they're really not taking up much of the volume, so that would be a low pressure. High temperature, low pressure, and as we can see, the best combination there would be B. All right, for number 8 and 9, we have a heating curve. 8 is actually a math question. We don't have a calculator. How much heat is required to melt 32 grams of methane? And the formula for methane is given at the top of the graph, CH4. So we have a mass. We need to change it to moles, because if we see that part Q is where melting would occur for this substance, and it has a enthalpy of fusion of 0.94. So we need to do some mental math. 32 grams divided by the molar mass of methane. So we've got carbon of 12, 4 hydrogen, so it's about 16. 32 divided by 16, yay, easy math, would give us 2 moles. And then if we double the 2 times the 0.94, that should give us a 1.88 kilojoules. Number 9 asks, in section S of the heating curve, the added energy is used to. If we look at S, we can see that's the boiling point. That's where the liquid is changing to a vapor. And notice the temperature is not changing, so we don't want to pick A, because that isn't true. B, it says break the carbon-hydrogen bonds. That it's a test to see, if this substance is boiling, it's a molecule, CH4, it's not held together. I mean, it does have covalent, valent internal bonds, but for the properties of boiling, it would be breaking its IMFs. And so which particular IMF? It would be C. It's a nonpolar molecule, and so it would only have London dispersion forces that would be broken. All right, question 10, another table of structural formulas and molar masses. So again, I think that just shows students, they're not going to have to see the word acetone and know what that is and how to draw it, but from the structure they should be able to realize, what the double bond O causes, or what the OH in 1-propanol should tell them, as well as butane having no oxygens, or which are no regions of polarity. So the question is, which of the following would have the highest boiling point? So again, we saw one that was lowest, this one's highest. So we're looking for the most polar molecule. It's not going to be butane, that's the one that's only nonpolar, so it's only going to have the London dispersion forces. If we look at the other two, they both also have London dispersion forces, but the C double bond O, that bond is not as polar as an OH bond. So that would be a site, the oxygen there would be a site of dipole-dipole. And then the OH bond in 1-propanol would be sites of hydrogen bonding. And so 1-propanol would have the highest boiling point due to its strongest IMFs. In 11, it says we have room temperature, CI4 is a solid. Which of the following, has that correct explanation? And again, this students hopefully would recognize what tells them that's a molecular solid. They just basically have to know the different properties of a molecular solid. So if they keep reading through, they'll see that C is the best explanation of a molecular solid. Not a good conductor. It doesn't have moving electrons. For 12, we have two substances to compare. Molar masses are given and boiling points. Based on the information table, which liquid has the lower equilibrium vapor pressure at 25 degrees Celsius? So the lower vapor pressure would indicate it has stronger intermolecular forces. This is the one kids tend to get backwards. But the stronger the intermolecular forces, the more likely the liquid is to stay a liquid. So therefore it would have a lower vapor pressure. So if we notice that the boiling point of CCl4, carbon tetrachloride, has a much higher boiling point, which indicates it has stronger intermolecular forces. So for 12, we would want to pick C, okay, because they're both going to be nonpolar molecules, but the carbon tetrachloride is going to have more electrons, a more polarizable cloud, and therefore stronger London dispersion forces. Question 13, we have water at a low temperature. Which of the following statements best helps to explain why the measured pressure is significantly lower than the pressure calculated using the ideal gas law? Since there is a low temperature, we know those water vapor molecules have low energy, meaning they're moving slower past each other. So since water's polar, really, when you have a gas, look for, and there's a deviation from ideal behavior, see if you have a polar molecule, because if it is, it's going to be C, the attractive forces between the water molecules cause them to collide with the walls of the container less because they're attracted to each other. For number 14, the question is which would have the highest boiling point and why. Again, we have to consider what are the forces of attraction between each of those. So neon, since it's a noble gas, would only have London dispersion forces between atoms. HF is eligible for hydrogen bonding since it has, one of those, it has fluorine, the most electronegative element, and hydrogen is present. The other two are both nonpolar, and so they would also only be eligible for London dispersion forces. So the answer is definitely HF. So we're going to pick B. 15. Based on the data in the table above, which of the following liquid substances has the strongest intermolecular forces? So again, since this is equilibrium vapor pressure, strongest IMFs means it's staying a liquid. So we want to pick the lowest vapor pressure, and so that would be D. All right, number 16, on the basis of intermolecular forces, which of the following elements would be expected to have the highest melting point? Zooming in on those, we can notice they're all diatomic. We'd really want to check out a periodic table. N2 and F2, are in the same period. Chlorine is below fluorine, and then bromine. So we can see that, these are all, even the nitrogen has a triple bond, it doesn't really matter. They all are covalently bonded molecules, and they're all nonpolar. So that means they all would have London dispersion forces between molecules. D is the answer for 16, since bromine would have the most electrons in the most polarizable cloud, it would have the strongest LDFs. For 17, which of the following substances involves the breaking of covalent bonds in order to melt? NaCl, we can, as we could see, oops, sorry about that. NaCl, and again, students would just have to go through and say, what kind of bonding is in each of these. So NaCl, hopefully they would come up with ionic. Sand, SiO2, hopefully that would stick out. That's one of those kind of oddballs, like diamond and graphite, that has that covalent network. So that is covalent bonding. That one's a little tough. Ice, when ice melts, unfortunately, some students are going to pick that, but when ice melts, that is the hydrogen bonds that are breaking. And then paraffin, you can see the carbons and hydrogens, huge chain, but still nonpolar, only has London dispersion forces. So our answer there for 17 is going to be B. Question 18 gives us the normal boiling points of the halogens as hydrogen halides, and it says the relatively high boiling point of HF compared to the others is attributed to, and again, hopefully students will remember that, it's, the smallest dipole moment means it's the least polar, which is not true. So hopefully they're going to zoom in on it's got to be an IMF. So 18 is D. Okay, 19, we've got which of the following are intermolecular forces breaking? So looking at the choices given, we see A, we've got carbon dioxide as a solid, like dry ice subliming, NaCl going from a solid to a liquid, diamond vaporizing, and then melting of iron. So, if the students go through each one, hopefully they'll realize that A, carbon dioxide is nonpolar, its LDFs are broken, B would be ionic, C covalent, and D metallic. So A is the only reasonable answer. 20, we have two molecules shown, and they're identified as glucose and cyclohexane. Select the answer as to which molecule would be most soluble, is more soluble in water. Again, no matter the structure, carbons and hydrogens equal a nonpolar molecule, so hopefully students would recognize cyclohexane as being nonpolar, therefore not being very soluble. And then the glucose, they might even hopefully recognize that name, but they could see the presence of many OH groups and even an oxygen in that in the structure itself. So hopefully they would realize that glucose is going to be more soluble, and they would pick answer B, because the hydrogen bonding could take place between those partially negative sites, oxygen sites on the molecule, and the partially positive hydrogens in the water, among some other attractions as well. So 21, using the information above, choose the answer that correctly explains the higher boiling point for methanoic acid. So we've got both structures, again, carbons and hydrogens and propane equal a non-polar structure. That's going to be LDFs, and then we see the methanoic acid has got the C double bond O, which is does give that O would have a partially negative charge, but then we see that OH, which is definitely sites of hydrogen bonding. So we want to pick, for 21, we want to pick choice B. Methanoic acid is definitely going to have the stronger hydrogen bonding as well as LDFs. 22, which of the following compounds would have the higher lattice energy? This goes back to Coulomb's law. If we take a look at these, we notice that D is not even ionic, so that should not even be considered. And then students might want to pick A, since those two ions are both very small, but again, charges trumps size. So we really should only consider B and C. And if we look at the size of Mg2 plus and Cl minus compared to Ca2 plus and Br minus, that would lead us to pick B, because Mg2 plus ion is smaller than the Ca2 plus ion, and therefore, chloride is smaller than bromide. So the Mg2 plus ion would be closer to the Cl minus ion, and that would be a greater attraction, which would have a higher lattice energy. 23, which of the following pairs of elements is most likely to create an interstitial alloy? That's the type where we're looking for one of the atoms in the pair to be very small so it could fit in the gaps of the larger atom. So if we look on the periodic table, we'll notice most of those are similar sizes, except for B. Aluminum is much smaller than lead, so we would expect aluminum to possibly be able to fit in the gaps between the lead atoms. The answer is B. 24. Why does NaCl have a higher melting point than NH3? Again, we're comparing completely different substances. Hopefully students would realize that. We've got an ionic compound versus a ammonia molecule, which is polar and could have hydrogen bonding between molecules, but ionic bonding is always stronger than an IMF. So we want to pick, one that correctly designates that. So D is the best answer for 24. 25, we have a picture of a developed chromatogram. We can see it's really two different chromatograms. One where the solvent moved up and separated 3 dyes, A, B, and C, and then the other one has an unknown. So in 25, it says, if water is a solvent, then which dye is most polar? And again, it's going to be, as you see, the water moved up to that line that's designated as solvent front. So whichever dye is closest to that front means it was the most polar and traveled the farthest with the water. So 25 would be C. And in 26, in the chromatogram above, what is the identity of the unknown dye? The key here is noticing, because some students are going to put B, the answer is actually, it's dye A. And the reason is the solvent did not move as far. And so literally, if you had a ruler, which, we just have to make an estimation, we take the distance dye A traveled and divide it by the distance of the solvent front, which we could see, if you notice, dye A traveled about halfway in between the origin and the solvent front, and so did the unknown. So we could definitely deduce, without even measuring, since it's traveling about half the distance, that it has to be dye A. All right, and then these last few questions, 27, which of the following best explains why the melting point of NaCl is lower than the melting point of calcium? And that should be fluoride. That needs to be corrected. And the reason here, again, it's Coulomb's law. We're comparing two like substances. So we would say that it's going to be a difference in charges. And so we know that sodium is +1 and chloride is -1, whereas calcium is +2 and fluoride is -1. So our answer here is going to be the charge of the sodium ion is less than the charge of the calcium ion. So 27's answer is C. All right, these last few questions, 28, we have an image. What do the dotted lines represent? Taking a closer look, hopefully students will realize this dotted lines are not bonding. They're called hydrogen bonding, which is really just an IMF attraction, so B is the answer. In 29, we have a picture of positive cations, and then you see the yellow, or these smaller circles have negatives in them, which would most likely describe, and notice they're all kind of in various positions, which of the following best describes the solid represented. And again, we're looking for an explanation because that's supposed to be a metal. So 29 would be D, it's malleable and a good conductor. And the last question, we see a picture of calcium ion. Those are water molecules, and what type of attraction is depicted between a water molecule and a calcium ion? And if we look at the choices, we would see that B is the best answer, since we have an ion attracted to a dipole, which is a water molecule.